In the PV laboratory of the Bern University of Applied Sciences, we are specialized on testing. That started about 33 years ago, where we evaluated the first PV systems. And there it was mainly about yield monitoring and also inverter monitoring. I'd say that's one of the USPs of our PV lab is we test things which cannot be tested by the private industry. For example, if there is an issue on electromagnetic compatibility, we could then test that both in our laboratory and out in the field. Our PV laboratory, as we have always been specialized in testing inverters, in testing PV inverters, I think it's like a natural process that we start to investigate the grid connection of PV inverters. And besides that, from my personal biography, I did my PhD in the area of grid connection of PV inverters to the low voltage grid. So I think these are two things which match together. In one hand, the tradition of our PV laboratory, and in the other hand, my personal specialization I did in the past years. You could imagine when you switch your lights on at home, somebody has to produce this electricity in right this moment. And traditionally in Switzerland, it has been hydropower station, which ramp up and ramp down the power according to the demand. In future, this will be still our hydropower stations, which manage this supply and demand, but not only, and especially in those times where we have a lot of solar production. And one example, what we do in our lab is we support the IEC in writing testing specifications, testing standards, to make sure that the PV inverters in future are able actually to manage the power grid. And then we also carry out these tests. Of course, there are many challenges in PV. It must be cheaper, it should be more efficient, it should be better integrated to the system. I think when it comes to applied research, especially the applied research we do in our lab, one main issue is also quality. And I think one of the challenges now is to make sure that the products we install, the inverters we install, the PV modules we install, that they last for a long time. So we must find ways of find out early if the quality is okay or not. And we must then coordinate or collaborate with the industry to improve those products. And we must advise our customers that they stop to buy products which fulfill the requirements. There are certain differences in these three regions. There are also similarities. So I think product-wise, it's all the same. We'll have the same products, the same PV systems and inverters in all the three regions. However, the challenges there are quite different. So in the cities, for example, I think there will never be a challenge for PV. There will be a challenge to find enough room, to find enough rooftops to install the PV systems, but the grid integration will rather be easy. That will be a challenge, for example, to integrate all the fast charging stations for electrical vehicles. When we come to the Midlands, there we have quite a few farming houses with huge rooftops, but the grids are rather weak. So there we do have challenges, and there we need different settings, different inverter parameter sets or control algorithms to stabilize the power grids by means of PV inverter control as well. And when we come to the Alps, there I think there we have most unknowns. If we will only have rooftop PV, I think the Alps won't be a big challenge because there are not so many rooftops. But if we start to build ground-mounted systems, and there are quite a few initiatives now in Switzerland, then I think we need to build even new distribution, even new transmission grids in the Alps to actually harvest this energy. To install PV systems and to buy solar electricity is the second best thing you could do, because solar electricity is the thing which will change most in our energy system. And the only thing which is even better, what you should do, that's actually to reduce your consumption and to save electricity. Don't lose trust, we can do it.